Hello, everybody. Thanks for coming to ARC205. My name is Paul Underwood. This is Keith Horwood here on the right. He'll be talking a little bit later. Talk about a theater. This is incredible. This is the closest thing to fulfilling a lifelong dream of being a magician in Vegas. I feel like Penn and Teller here. So thanks for coming today. What I'm hoping that you guys draw out of this session is whether you work for an enterprise or a startup or a medium-sized company, I think there are lessons that we can learn from startups on how to build and deploy on top of AWS. I myself am a AWS startup solutions architect, and then over the course of the last 2.5 years, I've talked to about 800 different startups, and I've had the opportunity to see the startups that are successful, the way they build on top of AWS, and I'm hoping I can bring some of those lessons that I've seen out in the field to everybody here today. So my expectations for you as the audience today is that you have some familiarity with the 100-level AWS constructs. I'm not going to be spending time today explaining what things like API Gateway or Lambda does. I'm assuming you guys have that notion already. The structure of the presentation, we're going to talk about 3 different architecture patterns, sort of in-tier architectures, containerized architecture, and serverless. And then for each of those patterns, we're going to talk about the implications the choice of those particular architecture patterns have from a cost, performance, and team structure perspective. And then in order to give you guys something that you can sort of walk away with today cleanly, my clicker broke, is a deep dive with Keith from Polybit. Keith manages thousands of different Lambda functions, both for himself and his clients. And I think that in the process of doing that, he's learned a lot of lessons that I think we can all benefit from hearing about. So when I started putting this deck together, I started thinking about, of those 800 startups I've talked to, what are some commonalities that I see? And I think most startups are expecting scale, either ideally having thousands of concurrent users or millions of concurrent users at some point. I think all startups are interested in differentiating themselves from competition or from other startups that might be competing with them, and so there's a real focus on features instead of standardization and internal process. I think a lot of startups have lean IT departments. Often the co-founder might be the only engineering resource on the team. And also startups have an innate appreciation for the fact that if they can keep their costs low, they can have a longer runway. But when I thought about that, I realized we're all thinking about that. This clicker. We're all thinking about that same thing. We're all wondering, we would all love to have an extra, pair of hands on our IT staff. We're all interested in developing features. We want to satisfy the those who own our requirements documents. And we all expect scale in some capacity once we move out of test or POC. So we're all here at reInvent today because, as attendees at reInvent, you're also probably very concerned about the well-architected pillars. Security, priority 0, it's table stakes these days. Performance, reliability, cost efficiency, all of these things are what draws us all here to reInvent. And amongst some of those best startups that I've talked to over the last 2.5 years, they've done a great job aligning some of these priorities together when they're choosing the architectures that they want to build on top of AWS. So how have people done in-tier architectures historically? And when I talk about in-tier architectures, I'm talking about the kinds of frameworks like Flask or Django or Spring, and sort of what is a common pattern that people see. And this should look fairly familiar to most of you. This is sort of a generic in-tier monolithic architecture. You've got a load balancer up at the front. You've got an application tier, ideally more than 2 or more application servers, and you've got your database in the back end doing synchronous replication to the standby. And ideally, those are in 2 separate data centers. So how are startups doing that on AWS today? Well, this is a pretty simplistic workflow that I'll walk through here. So the first thing we'll do is we'll just clone our code that we're looking to deploy, and then I can run eb init. And eb here is the AWS Elastic Beanstalk command line interface, which is different from the AWS CLI. And the EB-init command will actually create my high-level application. It'll automatically detect what code I've just cloned and make a guess about what language it looks like I'm trying to deploy. The EB-create command that you see there next will actually spin up the Elastic Load Balancer and the application servers and the database. PG restore, that's a common Postgres command. I just chose Postgres as an example here. And PG restore, maybe we're going to restore the database that EB create created for us into the database that EB created for us. And then the EB set environment command allows us to set environment variables. And at that point, in theory, I should be able to actually open my application and see it working. Now, of course, there's going to be changes. Things need to be made. And so if, let's say, I wanted to have a test environment, I can run EB create test, and that will create an exact replica of my prod environment in a test fashion, and also point my local Beanstalk workspace to point to a test environment instead of production. I then use my normal standard development workflow type git commands, et cetera. And then I can run EB deploy, will actually deploy those changes onto those servers that we just instantiated. Let's say we test everything looks good, our tests are passing. If I want to deploy that content or that new application and those changes into my production environment, I run EB switch prod, that points my local Beanstalk development environment to production now, and then I can run EB deploy, and that will deploy my changes into prod. So very clean path, very few commands to get that done. The EB CLI is a really, really powerful tool that integrates directly into your developer workflows. If you haven't used it yet, can't encourage you enough to do that. So what do we get with those commands? Well, just like that sort of generic architecture we saw before, we've got our Elastic Load Balancer on the front. We've got our 2 application servers and an auto-scaling group. And we also launched that RDS instance with the multi-AZ standby on day 1. Now, we also have a test environment that we created. And so you can see we've got a replica of that test environment behind it. But that's not all. We also get some benefits. This is clicker. We also get some significant benefits from Beanstalk. So Beanstalk will handle a lot of the IAM and VPC networking requirements that you might have tried to manage yourself in the past. Comes with CloudWatch metrics that you can get detailed CloudWatch metrics on your Beanstalk stacks, and also gives you the opportunity to use CloudWatch logs for your application logs. And then through EB extensions, you can also define additional specialist services like a Redis cluster or S3 objects, that kind of thing, in your EB configurations. So I like to call Beanstalk the cheat code to N-tier on AWS. It really builds you into the best practices from the start. And because the Beanstalk CLI works so closely with your standard development workflows, it's just a quick way to build into best practices right from the start. So what are the costs for this? What does the cost for this look like? Well, a development grade stack, which I characterize as a single T2 micro for the application server, single database T2 micro for storage. I don't need 2 of them because I'm not worried about high availability in production. And roughly, you could expect hundreds of concurrent connections against this development grade stack. The production grade stack is, in our case, using 2 M4 larges and 2 M4 larges for your database. That roughly costs about $320. Now, there's been some recent price reductions on the T2 and M4 instance families, so these numbers are actually a little high now. And these numbers also don't include some of our other cost-saving options like reserved instances or spot pricing. So just rough numbers to kind of give you a rough sense of what that stack actually costs. So talked a little bit about N-tier. Now let's talk about containers and how containers are sort of evolving and moving on top of AWS. Now, I think a lot of people may not understand this or visualize this right off the bat, but a proper containerized architecture might look very, very much like that VM-based architecture that we just talked about. You might have a Docker container for Nginx, providing your load balancing, SSL termination, light routing. You've got your application tier, maybe that's running your Spring app or your Django application. And then you may choose to run a MySQL container on on a Docker, in Docker as well, and set up and configure that synchronous replication yourself. Now, in practice, though, the best approach on AWS is to take advantage of the AWS ecosystem. Instead of you trying to manage and configure your own Nginx container for load balancing, et cetera, you could use our application load balancer to do the same thing. It can also do SSL termination and light routing as well. Obviously, you want to use Docker for your application tier, no surprises there. But I would also really encourage you instead of thinking about deploying your own MySQL container and managing that all yourself, use RDS. RDS is built, we manage it on your behalf. It doesn't require you to set up a lot of the configurations and synchronization and backups and all that. Just let RDS do that for you. So how does a startup today build something on ECS? So that AWS ECS login, that's actually from the AWS command line interface, and that's going to give us a really long username and password that we can use to log into the AWS ECS Docker repo. Then I use my standard Docker development workflow commands to build and tag instances or images into my Docker repo. And then, kind of like the Beanstalk command line interface, the ECS has its own command line interface as well, the ECS CLI. And that first command is actually configuring my local development environment to point to that specific cluster that I'm looking to deploy into that specific region. The ECS CLI up command is the actual mechanism that will launch the underlying container instances that my Docker images are going to be running on top of. Now, I can also use that ECS CLI to create a service based on a Docker Compose file. And then if I want to start that service, it's just a matter of simply saying service start. That's a really quick way to deploy Docker Compose and your images on top of ECS. Although, the gotcha here is that ECS CLI doesn't allow you to define application load balancing or autoscaling group details. To do that, if you wanted to supply that additional level of configuration, the ECS, the AWS CLI, has an ECS command that will allow you to specify a service definition file where you can include those details about how you want your autoscaling groups and how you want your application load balancers to be configured. So on the left side here, we've got our container registry that we logged into. We have our Docker files that we've defined and checked into that repo, or we built and checked into that repo. We've got our Docker Compose files, and we've defined those into services and tasks. Our container instances were launched by that ECS up command. So we're looking pretty good here. And so we're able to and then once that's all complete, we'll ask our services and tasks to be run by our scheduler, the ECS scheduler. Now, I highlighted RDS in here because those previous commands that we just showed didn't actually include RDS or define just launching RDS instances. That would be a matter of going to the console and launching it there or something to that effect. So ECS gives us some great stuff, but what about service discovery? I think there's going to be some announcements this week. I'm not sure if they've already come out yet or not about service discovery within ECS. How do you scale the underlying container instances? That's also something that's not done by the CLI. Instead, you'll actually need to create your own autoscaling group and let that autoscaling group launch your underlying container instances. So what does this cost exactly? So a production-grade EC2-based stack that we talked about is, like we said, $320 a month. A production-grade ECS stack is basically going to cost the exact same thing. The underlying instance types are the same. That said, a production-grade EC2 stack, you might only feel comfortable maxing out at 40% utilization for CPU or what have you, because if that one of those boxes failed, you want to make sure that other box is going to be able to handle that additional load. Well, in ECS, you're able to pack containers more densely on your underlying EC2 instances, and so you might be more comfortable actually running at 80% utilization because you've got the autoscaling groups with managing the container level scaling. So in a way, they're equal, but I believe that ECS gives you the ability to pack your containers a little more densely than you would have historically done on a conventional ECS and EC2 instance. So I want to talk a little bit about the stack challenge and how DevOps plays into that stack challenge. And this is the one opinion that I'm going to try to give today, and that's that traditional VM and container architectures are rooted in emulating physical classic servers. And because of that, they inherit the stack challenge. And Werner Vogels talks about this a lot. And really, I think I interpret the stack challenge to mean in a conventional EC2 instance, how do you manage the operating system? How do you manage the users who are allowed to log into the box, the files, your bootstrapping commands? These are all headaches that we all have to sweat and worry about. Now, Docker makes things a lot easier because we're able to kind of build these images with all of these things pre-configured, and we're able to check those Docker files into source control and things like that. That's nice. But we still have the underlying container instances that we have to worry about. We also have to worry about any supporting core services that need to be running on that container instance. For example, like console for service discovery or something to that effect. And so you're still inheriting all of the stack challenge, whether or not you're on Docker or on conventional EC2 instances. And so tooling gets us so far, right? We talked about Beanstalk, makes a lot of this stuff easier. Chef, Ansible, very popular tools out there today. But as your complexity scales, you're eventually going to need some DevOps staff. And that's because your developers are not DevOps folks. Your DevOps folks are thinking about process and standardization and consistency, and your developers are focused on delivering features. So what does that end up leading to? Even if you're running an agile shop, if you've got this separation of concerns between your developers and your testers and your operations folks, you're inevitably going to get yourself into a situation where feature 0 is being worked on and deployed by your ops team, while your dev team's already 2 features ahead working on that next feature. And that looks like a waterfall and may potentially lead to a lack of agility amongst your team down the road. So AWS, one of our major drivers for when we release new features or new services is we talk to customers, and we hear customers complaining about things like the stack challenge. And so, it's quicker. So AWS is back at the lab. We're talking with our customers. We're asking ourselves questions. We're listening to what our customers are telling us. And like I said before, because these traditional VM and containerized architectures are rooted in emulating classic physical servers, nobody really wants to care about servers. Let's treat them like cattle, not pets. Feature development, like I said before, is much more valuable than solving server-centric stack problems. Nobody wants to be writing glue code when they could be developing features. And scale is another issue. I mean, why can't things just scale automatically? Why do I need to scale on the increments of individual virtual machines or instances? So let's just put this server-centric architecture in a little historical context. The ENIAC 1946, it's interesting, the ENIAC is actually in the Smithsonian in DC, right next to R2-D2 and C3PO, which is, I find fascinating. But that was sort of, I'll kick that off as like the genesis of the monolithic architecture. 1979 process isolation came out, which sort of set the stage for containerization in Linux down the road. 2006, EC2 came out, and it's sort of a follow-on, sort of a generational follow-on from process isolation, and startups are now able to build and launch EC2 instances very quickly. But all of these things, containers, VMs, monolithic architectures, these are all server-centric. We're all thinking about servers. We're all thinking about that stack challenge. And so what's next, right? What moves us past? What's going to be the next evolution? What's going to be the next sort of influence? And I believe that's serverless technology today. Things like Lambda, things like API Gateway. So I think a lot of people are confused about how to define what serverless means and what exactly is serverless. So here's a quick architecture diagram of a serverless web application that you might deploy on top of AWS today. So first step is that maybe we chose Angular to be our front-end application. I'm a huge Angular fan myself. We're going to store the sort of Angular app and all the assets and images and stuff like that into our S3 bucket, and we'll front that with CloudFront. And that'll serve all of our example.com users when they come to example.com. So once that user's pulled up that app, they need to start making API requests. So we'll use Route 53 to configure api.example.com to point to, for example, API Gateway instead, and AWS Lambda behind API Gateway to handle those dynamic requests. For persistence, in our case, maybe we'll be using something like Amazon DynamoDB, and Lambda is perhaps reading and writing directly in and out of that database, and or perhaps even our clients could be writing and writing directly out of DynamoDB. And this is, in my mind, incredibly exciting, right? Where's the server here, right? Where's the operating system that I'm managing? Well, the answer to that is the operating system is AWS. And that's pretty thrilling. I mean, I talked about magic earlier, but I mean, this is, in a way, in my mind, an exciting, magical type of architecture because I am not worried about operating systems anymore. The only operating systems I'm worried about are the ones that my clients bought on their desktop or on their mobile devices. So how are startups doing that on AWS today? Well, there's historically been a pretty stiff pioneer tax that a lot of people have suffered through over the last couple years, or the last year or two. And Flourish is a service that we'll be announcing, we're announcing here at reInvent, which is designed to make things a lot easier for you to define in a sort of declarative markup language similar to CloudFormation, components and architectures like I just showed. But what else is really exciting about serverless and it's that you're going to have a much easier time talking to your CFO about what it costs. So we just talked about $320 a month for a server, but we didn't really talk about for that VM-based architecture. But I didn't, and roughly you might be able to get thousands or high hundreds of concurrent connections or something to that effect. But you can't really price. It's very difficult to price per user what that costs. But in the serverless world, because we're really paying for what we drink, we're able to actually price out what an individual user's activity might be over the course of a month. So imagine that website that we just, that website that we just described in a serverless way. Let's say you've got an average user visits about 10 pages a day, makes about 5 API requests over the course of those 10 pages, and those involve reads and writes and things like that. And you can see on the right, we're able to literally price out that monthly cost per user based on that access pattern. And this is similar. There are existing tiered pricing discounts as well that come into play as things start to scale, right? CloudFront data transfer, S3 storage, as that increases, there are tiered pricing models. So it might actually even be lower than this when you're at scale. But this is a fun conversation to have with your CFO because you're like, hey, I'm able to tell you exactly what it is per user. We know what the conversion rates are per user and how much profit we make, and it's a very exciting conversation because it completely changes the economic discussion that you might be having in the past with your CFOs today. So microservices is a evolving and sort of blowing up key word these days. And similar to what we just went through for what is serverless, I'm going to do my best to describe what microservices are, what a microservice might look like on day zero. So I think one of the most important aspects to remember, in my opinion, to think about when you're designing a microservice is that your developer who owns, or your developer or your team who develops a microservice needs to be responsible for all phases of the SDLC for that microservice. And that example architecture we just went through on the left here, it's completely reasonable to assume that an individual developer could own all of that and own the test and the dev and the operations and maintenance because they're no longer really sweating those heavy DevOps concerns that they inherited with the Stack challenge. They're now able to manage this themselves. Now, as complexity scales up, we need to think about splitting up that microservice. And I already mentioned Werner once in this talk, but he's a hell of a character. So I like to, he talks about microservices at AWS, or at Amazon rather, at large, and how we decide when the time is right to split up a microservice into, into two. And the answer at Amazon, at least, is when you cannot feed that development team with 2 pizzas, that's about the right time that you actually need to start splitting off that microservice, and that it should be its own. So in our case, in this example, we have our front end of our application. Maybe that's what that specific team is going to continue to own. And your core side API will sort of mitosis out from that existing service, and a new team will be responsible for managing that specific feature. So this process may continue on and on for a while, and to where you eventually might have 2, 3, 4 different microservices. And in this example, maybe each microservice team or each microservice developer has chosen to use Lambda and Dynamo and S3 as their primary mechanisms. But the key here is that they're all responsible for all phases of the SDLC within their particular microservice. I think that's very, very critical to the definition of what a microservice truly is. You may have a lead architect up at the front who is responsible for managing what I'll call the core services, the sort of relatively static definitions about what your DNS configurations, or maybe API gateway and what the RESTful contract, what that RESTful API should look like between your microservices. But the other thing that might happen is if service team 1 decides that they have the internal within their team the operational experience with Docker, and maybe they know that they've got lots of different small containers that they're trying to pack into lots of servers, let them choose Docker. You shouldn't be, when you're in a true microservice environment, what you're most interested in and what you're evaluating your teams on is based on how cost performant are they, how reliable are they, not so much are they following our standards and processes, are they following this. Let the service team manage the SDLC themselves and measure their success and measure their effectiveness based on well-architected pillars like reliability and security and things like that. And then perhaps service team 2 decides, well, we've actually got this particular service needs to handle thousands of concurrent requests per second consistently across the month, in which case, after they've done the math, they may have figured out that Lambda might be too expensive, in which case a traditional instance-based architecture might be more appropriate. Let your team pick the right tool for the job. Now, you may eventually have your big data guy come on down the road, and he owns Redshift, and he owns EMR or Kinesis or that sort of thing. And your mobile developer, maybe they own AWS Mobile Hub or Amazon Mobile Analytics. That's the, it's up, let your team own and pick what they need to be responsible for. So we've talked a little bit about what that in-tier and containerized architecture looks like on AWS. We've, and we understand the DevOps implication of the stack challenge, et cetera. But what about in a serverless world, right? I mentioned Flourish, but what are some practical techniques, practical things that you guys can leave here today to think about when you're going to deploy your next microservice or your next serverless architecture on top of AWS? And with that, I'm going to hand it over to Keith. And like I said, Keith manages thousands of Lambda functions, both for himself and his company, and for his customers as well. And so in the process of hosting all of those Lambda functions, he learned quite a bit about what it looks like to have that done in an organized way. So with that, I'll pass it to Keith, who will kind of walk you through some of those tips that he's learned over the last 2 years.
Cool. Thank you very much, Paul. So hi, everybody. My name is Keith Horwood. As Paul mentioned, I'm the founder and CEO of Polybit, where we've actually built Standard Lib, which is a central registry for microservices and a function as a service platform built on top of AWS Lambda. So as you can imagine, as Paul mentioned, we're already managing thousands of microservices for developers all over the globe, as well as our own services. And so I'd kind of like to talk to you about the process we go through for really unlocking practical serverless development. Serverless is cool, we're all interested in using it, but when it comes to actually putting it to practice, how do we start managing our teams around this? How do we organize around this? Right, so we've listened to Paul's talk, and great job, by the way. And you know what, we're sold. We want to go serverless. We're like, yeah, this sounds like a pretty good idea. Listen, serverless is scalable. It's scalable beyond your wildest imagination. Going from 10 users to 10 million daily requests, not a problem. There's decreased cost, which Paul mentioned as well, that maps directly to compute time. So from a finance and from an economic decision, it's a straightforward decision to make. One of the most important aspects is, Paul covered this as well, is organizational compartmentalization. And what this means is instead of having tens, maybe even hundreds if it gets unruly, of developers working on the same monolithic code base, you can really separate your development teams into the two pizza rule. I think Paul kind of hammered it down there, and separate your teams into smaller groups that are working on services that they pretty much just own and work as almost lean development teams, startups in their own right? And then there's also this Unix philosophy. Now I come from the Node.js and the JavaScript world, and so a lot of people are really happy with this Unix philosophy. The idea that it's service atomization, essentially. The fact that each service that you have, standalone service, you have separation of concerns, it does one thing and does it really, really well. And that's something that you really get to approach with serverless design and serverless architecture, and you really get to implement that on a team basis. So all this stuff is pretty exciting. Now before I go into the actual details of putting it like in the weeds and putting it into practice, I want to take like a giant step back and sort of touch on something that Paul very briefly covered, but it's how we really think about AWS at Polybit. Now, and especially with serverless architecture. Now, what we view AWS as is really the system architecture of the web, right? It's software configurable infrastructure. There are lots of ways to get anything done, as Paul went over a ton of different architectural patterns that your teams can use. But what's the right way? What's the best way? What's the most cost-effective way? How's my team going to be able to ship code and ship product quickly? So taking this perspective and seeing AWS as the system architecture of the web, we start thinking, relating it to really like the system architecture of a single computer. When a lot of people on the development teams that you're currently managing or working on, whatever, write code in JavaScript, for example, they write a function, and then they execute that function, and it just works. Did they have to think about memory addressing for that function, where that actually exists in the computer's memory? No. So when you think about serverless architecture, you're kind of thinking that kind of applied at the systems level, right? When I want to execute a service, why do I have to know geographically where that service is contained? Why do I have to know what VM that's running on, what container that's running on, where it's actually coming from? Why can't I just write a service and have it run? And so thinking about this next layer of abstraction and really the tooling required to make development around this next layer of abstraction tenable is really where we're focused. And in order to really build that abstraction layer, really what it comes down to is you're just thinking about organizational tooling for serverless architecture. So there are a couple of components here that everyone's on their own. I mean, this is a new space, right? Everybody's working on kind of figuring out, okay, how do we think about serverless microservices? Well, we got to think about 6 different components, really, right? There's sharing. How do we share? We built a microservice. How do we either share it with people in the global community or share it within our organization? How do we make sure people can access this and know that it exists? There's a discovery layer, which is kind of tied into sharing, in that a new developer joins your team and they want to build a service that accomplishes something specifically. Well, I mean, you could be a small startup and have only 10 people, or you could have hundreds or thousands of employees. You want to make sure that you're not reinventing the wheel every time you want to create a microservice. So how can you discover the microservices that have already been built? How do you manage development environments? I mean, there's a difference between going back to the old server-based development, but there's a difference between like a staging server and a development server and something you put out for release. How do you manage that? Now, microservice releases, you probably want them to be immutable, but development and staging environments, they could be potentially completely mutable, right? I mean, you can tear them down and spin them up whenever you want. You're not having any production-grade tasks relying on these, so how do you configure that? Deployment pipelines. What does that look like? I mean, there's been an explosion in open source tooling. around serverless. Even in the past couple of weeks, we've seen tons of stuff pop up. So what is the best deployment pipeline to use? How do I figure this out? And then versioning. I just mentioned service mutability for things like staging environments versus immutability for releases. If you have hundreds or thousands of microservices and you want to push out a new release, you don't want to just overwrite your last release and potentially break the interactions. I mean, it's a combinatorics issue, right? Break a bunch of interactions between pre-existing services. So how do you handle microservice versioning? And then there's legacy application interoperability. And this is something that's actually really exciting. It's actually pretty straightforward to take care of, but it's actually really exciting about the serverless space is that you can use legacy monolithic end-tier architectures that you've already built with and start deconstructing them essentially piecemeal and putting in microservices, serverless microservices running on Lambda in their place one at a time. So this is a really interesting perspective here. So how do we take care of that? I'm going to teach you kind of how we take care of that, and then I'm going to walk you step by step how if you want to build this stuff on your own, how you can take care of it within your own organization. So what we do at Polybit with standard lib, I mean standard lib, it's the missing registry for services globally, really. And we have some command line tools that really easily interface with our library. You can kind of almost view it like in the same way git push would, when dealing with version control, you'd use something like git push would push up the newest version of your code to a remote Git server. We have a command line tool called lib. You can just type lib up, and it instantly deploys your microservice. So very, very simple way to deal with microservice development, microservice creation, and this is all running on the system architecture of the web, like I mentioned, AWS on Lambda. And these are command line tools available on our GitHub repo at poly/stdlib, standard lib. On top of that, the second component to what we built is really, I was talking about this registry of services. When you want that discoverability, that sharing layer within your organization, now, you probably already use something like GitHub for version control, right? So you have developers come into your organization, they want to check out how code's been developed in the past, you give them permission to access your Git repos, they look at GitHub, they can see the documentation. Now, what about services that people in your organization have already deployed? I mean, this is an example of our registry page. One of our developers, one of the community members, built a stateless chess game where you can put in the state of the chessboard and a move, and it will give you it'll tell you whether it's valid or not, and give you the new state of the chessboard. So this is an example of automated documentation, really, that we provide that comes with building this service, so people can very easily organize around the microservices they build. Now, how do we do this behind the scenes? Like, right, you want to implement this in your own organization. Now, maybe use our tools, or maybe you say, you know what? No, we need something very custom, and I want to build it. I want to build it myself. So the first thing you want to look at is sharing and discovery. How do I really get this out to my organization? How do I establish some standards for the DevOps team, for the developers, on how they can actually access the microservice? Well, the first thing that we focus on at Polybit, I mean, this is one of the very first questions we had. Where do we put our microservices in terms of HTTP? And it's a super easy question to answer, actually. If you're running Bert's Shoe Company, bertsshoes.com, say, it's likely that you might have an API on api.bertsshoes.com. Okay, so how do we think about microservices? Well, we just prefix with the subdomain F, F for function. I mean, these are functional microservices. You're just thinking about deploying functions out in the cloud, so f.yourdomain.com/your service. Now, what's the pathway look like to actually execute this Lambda function? First, you're going to go through DNS routing, so obviously you have to set up your subdomain and the appropriate routing with Route 53, the AWS service. That will send you to API Gateway, which you can then integrate with your Lambda services. So this is like the de facto standard AWS suggestion for really how to start building with Lambda and API Gateway in this serverless context. Now, there are other ways that you can build this setup, and we'll talk about that in a little bit, where we can use almost a hybrid approach for the gateway if we need to do some complex computation before we talk to our service, but we'll get to that a little bit later. So that's the sharing and discovery layer over HTTP, f.yourdomain.com. Now, how do we think about environment and deployment? So, one, thank you to AWS and the AWS Lambda team for finally announcing environment variable support as of, I believe it was 11 days ago, as of today, for AWS Lambda. It makes dealing with environments and environment variables significantly easier. Now, we're going to cover a way that you can do this in a local environment from a developer perspective, and how we used to have to kind of do this and deal with environment variables on AWS Lambda, and kind of how we can do it now, now that AWS supports environment variables natively. So you'd have something like a .env file in your local development environment, and that's just basically going to be a set of key value pairs for environment variables and their values. So as an example here, I think we have a Stripe API key set up because you want to do payment processing from your Lambda function. So in your local environment, you would require this .env package. It's a Node.js package that will automatically load these environment variables. You don't need to do this in production on AWS Lambda anymore. So we'll talk about actually how to get your environment variables up and deployed with your service. OK, so now we kind of have an idea of how we can at least think about working with environment variables locally with this .env file. Now, how do we actually manage different deployment environments for Lambda functions, right? You want to create a microservice, a Lambda function, and you don't necessarily want to push to production right away, and you might have more than one development environment. You might have staging. You might have staging 1. You might have staging 2, right? You might have multiple teams working on a specific service. So the easiest way that we found to actually manage this is just by having, don't check these into version control, by the way, but by managing different .env files. And having, so for example, we have a development environment, a staging, and a prod environment. So you just prefix .env with .dev.env, .staging.env, .prod.env. You write a deploy command. I like to write a lot of stuff just natively with command line tools, just write command line tools in JavaScript. So I might build our deploy command in JS, in Node.js rather, but your DevOps team can configure that however they want. The idea here is that when you deploy to Lambda, your deployment pipeline should be able to accept some sort of end flag, and you can set prod to it, and then it knows to grab the .prod, just based on the string value prod. It knows to grab the production environment variables, package that into your system. Now, this is the old way of doing it, and you'd actually put it in a .env file on AWS Lambda. Nowadays, you can actually, as of 11 days ago, you can actually update the function configuration and set the environment variables that way. And so actually getting your service to Lambda from this deployment command that you're going to have to configure yourself, you're going to have to run some functions here from the AWS SDK. That's create function, update function code, update function configuration. How do we think about naming these on AWS Lambda? Instead of just calling your service, well, we can use Lambda versioning. Or what we do, because it's easier to manage from a DevOps perspective, is just add a suffix indicating the environment that your service is located in. So if your service is named your service and you're pushing it to production, you set _prod. This way, when your DevOps team or your software developers are looking at all of the functions available to you, they can immediately see, OK, this is production. I'm not going to touch this. I don't want to mess with this. But there's a few development environments here maybe we didn't clean up. We can delete that. It's not a problem. It's just for grokability and really ease of use. So your team's not freaking out, wondering what's in production and what's ready and what's not, right? So from there we go to microservice versioning. How do we deal with versioning? Well, AWS Lambda actually provides immutable service versioning, which is great. Now we want to map some sort of client request, like your service / a specific version to the specific Lambda version, right? Now you might want to name those versions. You might want to name them using like semantic versioning, which in Node.js land is the it's the de facto standard for how people do versioning. So how do you really create that mapping? Well, on your deployment, instead of specifying, now your DevOps engineer will typically be responsible for building a command line tool like this. Your deploy command would take a flag like version, and you'd specify a version. Now, how you actually deal with this using the AWS SDK is you'd set the publish when you create a function or update your function code, you'd set the publish configuration to true, and then Lambda is automatically going to create an immutable version of your service for you. And now you're going to get a number. That's just an integer value, like 1, 2, 3, the number that's essentially been published to AWS Lambda. Now you can create aliases, string aliases for any version number. So that would be like the standard way to do something. Like say you want to name your version Keith. You could create an alias that maps Keith to version 1 or version 2 or version 3. But oftentimes, you're going to want to do something that doesn't match that regex pattern that create alias supports. So you're going to want to do something a little bit more complex here. So this uses semver as an example. Now, a semantic version might be 1.0.0 for your first major, awesome production release. Same sort of steps. You'd set publish to true. you're going to get some number back as the version number. But instead of dealing with the create alias function, what you're going to do is you're going to create a DynamoDB mapping. So you're going to have a DynamoDB service set up, and basically just create a mapping saying this service with this string 1.0.0 is going to map to this specific Lambda service and this version number. Now this changes your architecture a little bit because this doesn't use API gateway in the standard way. And this actually sets you up in order to make use of this, you have to kind of set up a more hybrid approach where you get client request your service / version. You'd have your DNS coming in from Route 53 that's like f.yourdomain.com. And that's going to hit an Elastic Beanstalk gateway. Now this is a gateway. For scalability, you might actually want to build this in Node. You can build a gateway in something like Node that's basically going to take the client request, determine what version you're trying to hit, and then it's going to talk to DynamoDB really quickly and say, hey, what Lambda microservice are we trying to get here? It's going to get that information from DynamoDB, execute your service on AWS Lambda, and then return everything back to your client. And this is kind of what the hybrid architecture with this, what this really looks like. Now finally, the last point I made was legacy application interoperability. This is actually the easiest part. And this is the wonderful thing, the awesome thing about serverless. One, there's the AWS SDK. So you can use the tools that AWS has already built in a number of different languages to just call lambda.invoke and give your service name anytime you want to execute a function. Now, if you've kind of followed my advice here, and there's some stuff we've glossed over, like what your DevOps engineer is doing when they're creating these deployment scripts, et cetera. But if you've kind of followed our pattern for how we do things, you have f.yourdomain.com. That's mapping to most of your, if not all of your publicly available microservices. So you can now access all of these services just over HTTP. So every language that you work in is going to have, or the vast majority are going to have some sort of HTTP library for you to really easily just make a GET or a POST request or what have you to your microservice based on the gateway that you've set up for your services. So really easy to hook into your old legacy applications, whether it's an old Rails app, a Python app, you name it, easy to connect to. So just as a recap, what we've gone over here for practical serverless development and the organizational tooling around this, we've covered sharing, we've covered discovery, kind of at the same time, environments, deployment pipelines, microservice versioning, how you can think about that, and finally, legacy application interoperability. And the tools we used to cover this was, a full AWS feature set, right? Route 53, API gateway, AWS Lambda, of course, for serverless, the cornerstone. Elastic Beanstalk, if you want to build a hybrid gateway. DynamoDB, if you want to deal with this hybrid gateway and do some more computation on the gateway side. And then obviously Node.js tools and setting up your own command line tools, et cetera. Now the alternative, you're welcome to build this, and I'm happy to talk to any one of you after this talk is over by email, in person, whatever, about how you can start setting this up within your organization. The alternative is you can work with the solution that we've already built with standard lib. We literally take care of all of this for you to make it super, super seamless and easy. I've talked about our command line tools here. Super easy to build, super easy to test. You can test your services locally or in the cloud just using a single F command. It's essentially just wrapping curl. It's very straightforward, very simple. We're very proud and excited about what we've developed here. And really, we take care of all 6 of these concerns that I've spoken to you about now. So to finish up, before I give you back to Paul here, like I said, I'm Keith, founder and CEO of Polybit. We're building standard lib. We wouldn't be anywhere without our developer community. So I invite you to join and become a part of it. We're really happy, excited to be presenting here at AWS reInvent. Happy and excited to be aligned with Amazon. We're your library for microservices. You can download a copy of this talk at standardlib.com/reinvent-2016. If you want to see a copy of my portion of the talk. You can follow us on Twitter at Polybit, or follow me specifically at KeithWHOR. Thank you very much, and now I will turn it back to Paul. Thanks, everybody.
Thanks, Keith. All right, guys. Just want to leave you with a final thought. When you guys are leaving reInvent on Friday or Saturday, whenever you guys are taking off, and you're going into your next architecture planning session next week, I would encourage you to think about these sort of 8 concepts and spend the time really defining the boundaries and what's most important for that workload that you're about to try to tackle. And I think what you'll find is that a well-defined microservice will imply its own architecture. Keith and I will be probably right outside of the theater after this to take any questions. It's just kind of too big of a room to like actively take questions and things like that. So we'll be right outside if you guys want to ask us any questions or come get a card or come talk to us about serverless. Please take your time and fill out the survey if you don't mind. Let us know how we did, and so we can try to make this better for you guys. Thank you very much, and look forward to meeting some of you guys out front.